In this video, we are going to talk about the floating point unit. Hi everyone, I'm going to talk to you about the history of the floating point unit. First of all, it's important to understand that the floating point unit comes to solve the problem described in the figure because it is able to process both large and small numbers with a floating point to make arithmetic operations like addition, subtraction, fractions, and more complex operations. About the history, we decided to focus the attention in Intel. At the beginning, Intel didn't have processors to operate with floating point numbers to make operations. So this functionality was emulated by software, but the process was too slow and required special abilities from the programmers. So Intel decided to implement this functionality with hardware, and the result of this decision was what we know as floating point unit. Before the first floating point unit was released, there was a problem related to the representation of these floating point numbers, and this because to solve a mathematical problems there were many ways to represent the result of the calculations. So it was necessary a standard to represent the results of the floating point numbers in a computer. This standard was called 754, which was approved until 1985. And because the standard was approved in that year around the 60s and the 70s, the programmers have to deal with the different representations of these numbers according to the different brands of computers. Despite all the complications related to the representation of the floating point numbers, in 1976, Intel began to design the first floating point unit. Dr. John Palmer was in charge to lead this project, and also he was responsible to persuade Intel to embrace the standard mentioned before to prevent their processors from giving different math results. The floating point unit design tests were carried out on their 8086 and 432 processors. It wasn't until 1980 that Intel launched Intel 8087. This was the first coprocessor to implement the floating point unit for the 8086 line of processors. The goal of the 8087 was to speed up the floating point calculations. Intel saw floating point instruction processing as an opportunity for his processors to stand out from the competition. By today, not only the floating point unit is able to process floating point instructions, also the CPU and the graphic processing unit can perform this task.
A floating point unit is an integrated circuit that handles all mathematical operations that have to do with floating point numbers or fractions. It is a dedicated logical unit specifically designed to work on floating point numbers and nothing else, hence the name. It can be defined as a specialized code processor that can manipulate numbers faster than basic microprocessor circuitry. The floating point unit performs simple math tasks including addition, subtraction, division, multiplication, and square root. Other floating point units handle momentous functions like exponential and trigonometric calculations, but this can be expensive and cumbersome to implement. So, in modern floating points units, they are the true software libraries routine. It is important mentions that is not just a small part of a computer, but an integral part of the system. It is usually implemented through hardware, but not all computer systems might have a floating point unit due to various reasons, including space, power, and price. Not all computer systems have floating point hardware, thus with the floating point unit can emulate its functions in multiple ways. First, I am operation system and inference functions. Second, can be emulated in the processing unit. Third, in user code, typically this is what is called software emulations. A floating point unit is more complicated to implement in hardware, but fortunately it can be emulated by the central processing unit. In a sense, it can be part of the central processing unit. It can be implemented as a firmware within the central processing unit. Is in such a case, the central processing unit now performs all the functions of a floating point unit, but it is less efficient than a dedicated floating point unit, as this would take a valuable central processing unit time that would have been used to process other things. Emulation can also be done by the operation system or by software. In every floating point number, there are three components. Sign indicates the sign of the number, 0 is positive and 1 is negative. Mantissa contains the magnitude of the number in pure binary, and 3 exponent contains the value of the power of the base. The base most used is 2. Integers and floating point numbers can be compared to the floating point units and convert from one precision to another. They can also be rounded in any directions and stored directly in the main memory of the process. In addition to the above, the floating point unit of a graphic processor may include frequently repeated functions that are common to the rotations and animation of three-dimensional objects. Many implement controllers are designed with processor optimized for digital signal processing. This can be used in audio and communications application and can contain floating point units, which are good for fast Fourier transforms, for example. Crypto processors often include a floating point unit for high-speed computation of most intensive encryption algorithms. General multi-core processor may also include a floating point unit for each normal processor core.
How does floating point unit works? Floating point numbers have decimal points in them. The number 2.0 is a floating point number because it has a decimal in it. The number 2, without a decimal point, is a binary integer. Floating point operations involve floating point numbers and typically take longer to execute than simple binary integer operations. For this reason, most embedded applications avoid widespread usage of floating point math in favor of faster, smaller integer operations. FPUs handle mathematical operations related to floating point numbers. So, when a CPU is instructed to calculate 125 by 16, the equation will be processed as an integer operation by the integer processing unit. However, If the CPU receives an instruction to calculate 5.051 by 11.03, the request will be sent to the FPU. Note that the CPU can handle floating point calculations even without integrating FPU. However, the process will be slower as integer operations differ from floating point calculations.
CPU and GPU. Both are microprocessors that are responsible for different tasks. First, CPU. This is a abbreviation for Central Process Unit, and a computer CPU process of the instruction that the main processor receives from the hardware and software running on the computer. The CPU is often referred to as the brain of the computer, but this is not entirely correct, because without the appropriate software, that something's enormous computing power is worthless. If the computer doesn't have a CPU, a GPU, which is specialized in rendering 2D and 3D graphics, the CPU performs this task but with less capacity. Now, what is GPU? This is an abbreviation for Graphics Processing Unit, and the graphics processor, initially without computing capabilities of this sound, and was a period output device. It is now a processor that has tremendous computing power and over outperforms the main processor. The GPU is geared towards rendering graphics, be it 2D or 3D, but it has been discovered in recent years that it has a hiding capability. This ability is to do the process that the FPU performs but much more efficiently, due to its great power. And these units are separated for the CPU and are now has a video cards and graphic cards. And therefore, being separated from the CPU, the computer will use the letter of the other process and thus performs tasks much more efficiently. Difference between FPU, GPU, and CPU. A CPU is an all-in-one tool. It is designed to perform many types of tasks as quickly as possible. In particular, they have a great optimization for decision making. For example, if such an action is performed, then perform this other action, else perform this other action. CPU can perform types of tasks like arithmetic or mathematics, logic, loading and storing in memory, or registers, but they are generalist. The FPU usually builds a co-processor for a CPU. That is, it performs floating point operation on behalf of the CPU that it controls. The CPU could perform this floating point calculation, but it would take a lot of time and resource. Plus, the whole computer would slow down. So, doing on a normal CPU is not productive. In this case, the FPU comes into play, which is in charge carrying out this task loaded in the logic and log process. The FPU performs all relevant calculation while the CPU performs other tasks. And after the FPU completes, the CPU reads the result and performs the following action indicated by the user. The reason for the creation of the GPU is to render graphics. However, users have found that the GPU is highly optimized to perform a large number of floating point operations in parallel. Because to render graphics many times, you must perform this operation on better data. To perform mathematical calculation, or simple logical process, using a GPU is a waste. But to perform operation on a very large set or require a lot of logic, they are perfect.